we have reduction and oxidation reaction. Now we're going to take this here one after the other. The actual reactions here, so we're going to have, let's say, reduction. Other reaction we have reduction to alcohol. Or we have the next one, reduction to hydrocarbon. Okay. So both the aldehydes and ketones can be reduced to alcohols, and they can also be reduced to hydrocarbon. Now, what differentiates the product you are going to have, whether it's going to be an alcohol or whether it's going to be a hydrocarbon, right? Is basically the reagents you are going to make it on. Alright, so let's take the first one. Reduction to alcohol. Reduction of aldehydes plus ketones listen up. Aldehydes are reduced to primary alcohols. Aldehydes are reduced to primary alcohols, whereas ketones are reduced to secondary alcohols. Aldehydes are reduced to primary alcohols. Ketones are reduced to secondary alcohol. Now, if you remember, when we treated alcohols, like one of the reactions of alcohol was oxidation, is it not so? When we said alcohols, when oxidized, right, goes to aldehyde first, and then goes to carboxylic acid. So, secondary alcohols goes to ketone. And I told you that tertiary alcohols are not readily what oxidized. Now, oxidation is the opposite of reduction, do you get? So if I have oxidized primary alcohol and then I'm getting aldehyde first, that means if I reduce aldehydes, I can get what? Alcohol. So take note of this. Now, how will you actually ask this question in exams? If they make mention of reduction, that means they're giving you guys a clue. But most of the times, they will not mention reduction. They will just say, give the product of the reaction when initial reactions to compound. So it's best for us to know the type of reagents that when we react aldehydes or ketone with, we know that it's reducing reduction. So let's look at the various reducing agents that can reduce aldehydes and ketones to alcohols or to their respective alcohols. Now, reducing agents, we have many of them. So let me jot them down. The first one we have lithium catalytic hydrogenation. Catalytic hydrogenation. That's reaction of hydrogen in the presence of the catalyst, either platinum, palladium, or nickel. Now that's what we mean by catalytic hydrogenation. Now you add hydrogen in the presence of the metal catalyst. One example of this metal catalyst, platinum, palladium, and what? Nickel. Alright, so the next one is sodium borohydride, NaBH4. We also have the next one, lithium aluminum hydride. We have lithium. So take note of this. Anytime we see an aldehyde or a ketone reacting with any one of these, That is reduction to alcohol. Of course, I'm going to give us a series of examples to explain this. Once you are done, we're going to look at reduction to hydrocarbons. And after we look at oxidation, and then we are done with this part of the end. For example, now we have a few examples here. Right? This is butane, sugar, this propanol, and this propanol. Now remember, these three examples, the expected products are meant to be alcohols. Now, how do we reduce this guy? Come to this carbonyl group, add one H here, and add one H to the carbon. Add one H to the carbon, add one H to the carbon, remove the double bond. That's how you get the reduction. So you come down to this guy, this becomes CH3, CH2, CH3. Now this becomes 4H, and it becomes CH. Recall that I told us earlier that this is ketone. Ketone is reduced to secondary alcohols, Yes. But then 2 only ketone, right? So when you add one H here and then add one H here, now we're going to get alcohol. This is actually a secondary alcohol. Carbon is a carbon bearing. Alcohol is a carbon bearing the OH attached to 2 additional carbon. So this is butane 2-bond. This was butane 2-bond. We'll move from ketone to alcohol, right? Yeah. Now you come down to this here in the same pattern, remove this double bond, put H here and put H here. It becomes CH3, CH2, this, put H here. Remember there's already one H, right? Yeah. So when you put additional H here, it becomes what? CH2, and here becomes what? H. Now this is an aldehyde, propanol. Propanol will give us a primary alcohol. Primary in the sense that the carbon bearing the OH is attached to just one carbon. So this is actually propan 1O. Now remember these three reagents, they are going to give the same results. Add one H here and add one H here. This becomes CH3. Alright. These are the next reduction reaction. Remember we said we have 2 types of reduction reaction. The first one is going to give us alcohol, while the second one will give us hydrocarbons. Now the 2 reagents that can reduce aldehydes and ketone directly to hydrocarbons are called the Clemenson reagent and the Wolff-Kishner. And most of the times, they might not mention this reagent in the question. If they mention the reagent in the question, it's already important. Do you get? But the reagent is zinc amalgam. Amalgam means mercury. So this zinc amalgam is ZnHG. This is zinc amalgam in the presence of concentrated HCl and heat. Right? Yeah. So whenever you see this, just know that this reaction is going to convert the aldehydes of ketones to hydrocarbon. And what do I mean? Hydrocarbons are compounds that contain only carbon and nitrogen. But aldehydes and ketone has oxygen, right? Yeah. Anyway, you see oxygen, remove it and put hydrogen. Anyway, you see oxygen, remove it and put what? Hydrogen. Because this oxygen is having how many bonds? 2. And one hydrogen is active part 1, right? Yeah. So this is going to be CH3, CH2, CH2, and what? CH3. From butane 2-bond to butane. The same thing that this is Clemenson reagent, zinc amalgam in the presence of concentrated acid and heat. Give us this. Now, this guy is Wolff-Kishner. The same thing. Now, if somebody may want to ask, so what is the difference between this and this? Let me tell us this. This reagent is stable in an acid medium. This guy is stable in a what? Acid medium. Why is this guy stable in a what? Acid medium. Take note of that. So we use this guy in an acid, we use this guy in a what? In space. The work of this guy is just to convert the CO to CH2. Period. So I come here now, CH3, CH2. That is the only one thing here. Right? If you remove this whole, you add 2 hydrogen. 2 hydrogen in addition to this guy becomes how many? 3. Right? If you remove this oxygen, you put 2H. Right? There's already 1H here. Is it also? So this guy now becomes what? 6H3. So this is propane. So that is what this nutritional reagents and clemency reagent is all about. They reduce aldehydes and ketones to hydrocarbons directly by replacing the CO with CH2. So that is it. Alright, so let's explain this. I said that oxidation reaction is the only reaction that distinguishes aldehyde from ketone. Now, aldehydes are organized to carboxylic acid. You could remember when we were talking about primary alcohols, we said primary alcohols oxidizes first towards aldehyde and then subsequently to carboxylic acid. Now, ketones are not oxidized readily. So realize that this is the only reaction that aldehydes undergo that ketone does not undergo. So hence it's used as a case or a test to distinguish both of them. Now, the tests for aldehydes and ketone are mostly done using the Tollings reagents. Right, so when we are done with this, we're going to look at the text for aldehydes. Now, these are the common oxidizing agents, right? So let's see how this is going to actually, take place. So let's say the examples. We have the first one, which will be reaction of ethanol. Let's use propanol. Which let's say propanol, CH3, CH2, CH2. This is propanol, and this is propanol. Now this is propanol. Now we're going to use the same oxidizing agent here. I'll come here, I'll put this KMNO4. Please take note of this, that any one of these could be made equal. So I come here, I also put KMNO4. Now this stuff you're seeing here is more like O and H. So it's basically oxidation of this guy is addition of oxygen between the carbon of the aldehydes and the hydrogen. Right? So when you do that, it becomes CH3, CH2, CO, what? OH. Now this becomes the oblique acid, COOH. So we are moving from this CHO, that's the aldehyde functional group, to what? CO. That's the oxidation functional group. You understand? Now, because this is an aldehyde. In the case of ketones, plus, there will be no reaction. Because this is a ketone. How do we know that it's a ketone? The carbonyl group is bonded on both sides by a carbon, right? Whereas in the case of this, the carbonyl group on one side is hydrogen, on the other side is what? Carbon. So the oxygen enters between the carbon and the what? Hydrogen. But in this case now, there is no hydrogen to capture the hydrogen. So this becomes no reaction. Now, let's look at this particular reagents, Tollings reagents. Tollings reagents. So say tests for aldehyde. Remember, if I want to test for aldehydes, I'm going to use oxidation reaction because it's the only reaction that aldehydes will undergo that ketones will not undergo. So we use it as a test. Alright? So imagine somebody bringing two compounds and you're being asked or you're being told, oh, these compounds, I don't really know which of them is an aldehyde and which of them is a ketone. But I know that one of them is an aldehyde and the other is a ketone. Can you help me distinguish between two of them? I'll subject that guy to a test. And the reagent I'm going to use for that test, the reagents we are going to use for that test is what? Is Tollings reagent. Tollings reagent. And Tollings reagent is ammonical solution of silver nitrate. So this is Tollings reagents. Most of the time they don't put the OH. They can just put this just alone. Right. And that test, the test is called what? Silver mirror test. Now, how is this silver mirror test? I'll give you an example. Imagine bringing a test tube. A test tube is actually transparent, is it not so? You can see through the test tube. And then after reacting with aldehyde in this reagent, this silver is going to deposit on the wall of the test tube, right? The silver, because if you react this reagent with aldehyde, the silver in this reagent is going to deposit on the wall of the what? Test tube, such that when you look through the test tube, you're no longer going to see, you're no longer going to be transparent, but instead a reflection of yourself. Your mirror at home, you know that your mirror in the house has a blank water paper. If you remove the blank, it becomes transparent. So that's what we mean by silver mirror test. So I say the test is called silver mirror test. Class notes, in this silver mirror test, aldehydes, this particular point is very, very important. Aldehyde gives a positive test. Gives positive silver mirror test. Aldehyde gives positive silver mirror test, whereas ketone gives what class? Negative. Whereas ketone gives negative silver mirror test. So we've actually stated the fact that the text that is used to distinguish between aldehydes and ketones is an oxidation reaction, and that test is called silver mirror test. The reagent we are making use of is a mild oxidizing agent, not at all. So let's look at a reaction. Let's look at this reaction. Now we take the first one, CH3, C. This is an aldehyde. Now we have this. Now once you see this is the cooling reagent. If you take a part picture, I'm pretty much sure that there's something like this. Ammonical solution of silver nitrate. Now these are aldehydes. So the product I'm going to have will be a carboxylic acid, COH. This guy is a mild oxidizing agent, which is going to oxidize this guy, and itself, the silver is going to deposit. Remember, there was a time we got hydrogen like this. It is a gas. The gas before goes out, but the solid does what? Comes down, deposits. So that is why we have this guy. Then this is an aldehyde, so it oxidizes this guy to ethanoic acid. That's a positive silver mirror test. But this second guy is a ketone, right? There will be no what? Reaction. So there will be no reaction. So ketones gives a negative silver mirror test, whereas aldehyde tests positive to silver mirror test. Please let me do this way. Ketone tests negative to silver mirror test, whereas aldehyde tests what? Positive. Remember, the silver mirror test is a test to distinguish aldehydes and what? So in exams, I think in your past section they say silver mirror test is used to test for aldehyde, true or false. What's the answer? True or false? Why is it false? Someone said false. The answer is true. We use silver mirror test to test for aldehyde, right? So the answer is true. All right, so that's that for this oxidation of aldehydes.